Hey you friends, what's up? This is your dear friend Apurva Jagtap and welcome to my channel, the Math Genius Tube. Today we'll be seeing type 4 category sums, that is sums on change of scale property. This is the major concept in Laplace transforms 1. You should know how to change the scale. Basically, till now we had seen sums wherein we had to find Laplace of the function, plain function, that is f of t. But now what if your function f of t is associated with a constant called a? So there's the time where we need change of scale property. So now this is the property, that is L of f of at is equal to 1 upon a into phi of s upon a. So now let us solve few sums on it. Okay, so this is the first university question that's popping up on your screen right now. It's basically a proof question and it was asked many times in the Mumbai University exam. So okay, if L of f of t is equal to phi of s, then prove that L of f of at is equal to 1 upon a into phi of s upon a. So now let us see how to prove this goddamn property. So step number 1, write the Laplace transform definition. Write the basic Laplace transform definition that we had seen in the first video lecture. That is this property. Therefore, L of f of t is equal to integral 0 to infinity e to the power minus st f of t dt. That is the advanced version. Therefore, L of f of at is equal to integral 0 to infinity e to the power minus st f of at dt. Now mark this equation as number 1. I'll tell you later on why. And now this is the important step that you need to remember in this particular proof. That is, put u is equal to at, or you can also put t is equal to u upon a. One and the same thing. Okay. And now I'll be differentiating that is this thing. Okay. So after differentiating I get this. Du is equal to a into dt, or if you substitute this particular thing, you'll be getting this after differentiation. That is dt upon du upon a. You can substitute any of the one. Okay, so after substituting this particular thing in the equation number 1, I get this step. That is, therefore L of f of at is equal to integral 0 to infinity e to the power minus s into u upon a into f of u into du by a. Now guys, as you can see that this particular equation is in terms of u and s, not t and s. Reason being, I had substituted u equal to at in this. Okay. Now guys, I'll be pulling out this 1 upon a out of the equation just because it is a constant. And now finally I get this step. See? Okay. So the next step, in this next step, what I'll be doing is that I'll be making this equation uniform in terms of u. Now instead of t, I will be making this equation uniform in terms of u. And now guys, I want you all to be a good observer over here. I know this is gonna be a lame concept, but this is how you can remember and prove this sum. Okay. So now guys, as we had seen in the first lecture, you had seen this definition. Phi of s is equal to L of f of t is equal to integral 0 to infinity e to the power minus st f of t dt. Now guys, just observe over here. The power of e over here is s and t. But see, main emphasis on s. So therefore, you can write it as phi of s. I know this is lame, but just to remember, you can do this. And see, over here, it is the power of e is s upon a. Therefore, please finish off the matter. Just write phi of s upon a. Yes, so phi of s upon a can be defined as this. So therefore, this is the proof. This is how you can try to remember it and solve it. So therefore, L of f of at is equal to 1 upon a into phi of s upon a. And hence, proved. The bitch is proved.